is the HVAC system? The HVAC stands for Heating, Ventilation, and Air Conditioning. It is used for heating and cooling both of residential and commercial buildings, as well as the various systems used to move air between indoor and outdoor areas. The primary goal of this system is to control the temperature and humidity in occupied spaces, as well as the provision of proper ventilation. Generally, buildings need to install the HVAC system because they are used for controlling the overall climate in a building. Second, they enhance the productivity in offices as they feel comfortable. And last, they improve the air quality in the building, making it suitable for human breathing and comfort. Let's go on to the basic components of the HVAC system. Mixed air, plenum, and outdoor air control, air filter, supply fan, exhaust or relief fans and an air outlet, outdoor air intake, ducts, terminal devices, return air system, heating and cooling coils, self-contained heating or cooling unit, cooling tower, boiler, control, water chiller, humidification, and dehumidification equipment. Let's now proceed to the HVAC system for assembly buildings, such as theaters, cinema halls, or auditoriums have high-density areas. As a result, the amount of fresh air required to dilute the CO2 concentration is high. Since humans emit a greater amount of latent load when there is a high occupancy rate, all these factors must be taken into account by the designers when calculating the air conditioning load. Typically, the comfort band on temperature ranges from 70 to 76 degrees Fahrenheit, with a relative humidity of no more than 65%. The control of noise and vibration is also another important criterion. The desired noise criteria vary depending on the facility's type and quality. Noise control is less important in cinemas, but it is critical in theaters, auditoriums, and concert halls. In most cases, both mechanical equipment and the air distribution system require sound and vibration control. The air distribution for assembly buildings. The design of HVAC systems for assembly buildings requires that specific requirements being fulfilled. Due to the higher temperature sensitivity of the normally sedentary occupants and the extremely high acoustical needs of such areas, special attention should be made to providing better comfort and low levels of noise. When thermal comfort is not easy to achieve for people who are seated and inactive for prolonged periods, as their bodies do not require much heat removal and are prone to feeling draughts, this is where the high-level air distribution systems takes place. The air is traditionally supplied at a high level so that both mixing of cold supply air with warm room air and high air velocities produced by supply air streams are restricted to the zone above the occupied space. Another type of distribution system is the low-level air distribution system, where it is combined with high-level extraction and are designed to improve levels of comfort and air freshness and to reduce system capacity requirements by restricting conditioned air to the occupied space, by allowing heat and pollutants emanating from this space to separate into a hot, high-level blanket of contaminants, and by exhausting this concentration of heat and contaminants to the outdoors. Possible heat came from heat gain through the windows and doors, heat gain due to people, heat gain due to lighting, heat gain due to appliances, and heat gain through walls and roof. The description of the conditioned space and the HVAC system. The space under consideration is a 250-seat university auditorium that is located on the ground floor of a 5-story office building and is primarily used for classes and lectures from 9 a.m. to 9 p.m. on weekdays. A single duct, single zone, constant volume, all-air HVAC system, an air handling unit, an air duct distribution system, an electrically driven chiller, a gas boiler, a humidifier, A piping network in a control system make up the HVAC system of the assembly hall. When putting the layout of the HVAC system on the building, the air handling units with increased cooling capacity should be zoned separately for the auditorium, lobby, projection spaces, stage areas, and audience seating areas. The floors should be raised, and a recommended system for the distribution of the HVAC in the building is ducted supply through the floor vents with ducted ceiling return air vents in the auditorium and the lobby. The single duct system uses a single fan to supply cool air or warm air to zone terminal units. Fresh ventilation air is pulled into the air handling units by an input diffuser and mixed, if necessary, with air returning from the conditioned room in a mixing chamber. The air-to-air fixed plate cross-flow heat exchanger. It is used in this HVAC system. It is used to recover sensible energy, delivers the humidified ventilation air, and it is used where the ventilation cooling load accounts for most of the system cooling load. The control system. The control system regulates the operation of the HVAC system, which allows to respond to variations in load and ventilation requirements to maintain acceptable indoor air quality and in thermal comfort conditions while operating the plant efficiently and saved energy. The control system are equipped with sensors and a central controller, which regulates the position of the three-way valves installed at the heating and cooling coils, the steam flow from the humidifier, and the position of the dampers at the mixing box. Fresh outdoor and consequently exhaust airflow are regulated according to occupancy. These two airstreams pass through the air-to-air. The system operates with the economizer cycle. When the temperature of outdoor air falls between the exhaust air temperature and the indoor discharge air temperature. The air conditioning system designed for the assembly halls. An air conditioning system is used to provide comfort for humans by establishing suitable conditions in dwellings, work environments, assembly halls, and other areas of humidifying or dehumidifying the air and maintaining the air temperature level. When selecting an air conditioning system for a specific application, these are the factors we should take into consideration. The system constraints, where zoning regulations, cooling load, heating, and ventilation takes place. The architectural constraints, where acceptable noise level, space available to house equipment, and its location relative to the conditioned space, and acceptability of components in the conditioned space are all factors to consider. And the financial constraints, where we should calculate the cost of capital, cost of operation, and the cost of maintenance. There are three primary aspects to air conditioning system: the central air conditioning units, the room air conditioning units, and the fan coil units are the three types. There is a single source of conditioned air in central plant air conditioning units, which is circulated through the building via network of ducts. Refrigerant is used in room air conditioning devices to provide cooling effects. To produce conditioned air, fan coil air conditioners use chilled water instead of refrigerant. Room air conditioning units fall into two main categories: the split units having an indoor and outdoor unit, and the window and wall units with an evaporator on the inside and a condenser on the outside. The split room air conditioners feed cold refrigerant to a cooling coil into the interior unit. The outdoor unit uses a compressor and an air-cooled condenser. Window or wall units are supported by a metal frame and placed into a suitable hole in the window, and are constructed into an exterior wall and contain all the necessary equipment to give cool air. Now, why is the HVAC system design important? The HVAC systems consume 39% of the energy in commercial buildings. Customized designs are used by industries to use or emit hazardous chemicals to help increase efficiency and keep emissions within Environmental Protection Agency guidelines. The distinct characteristics of each facility have an impact on the overall design, size, and positioning of an HVAC system. These systems, if well designed, can assist manufacturing plants in focusing on production while also lowering energy costs.